All right, let's get into it. We're going to explore how a really ancient piece of tech can actually tell us something incredibly profound about our very own minds. So we're going to start with the mystery from the Inca Empire. This thing right here, it's a device made of knotted strings called a quipu. And I know, at first glance, it just looks like some kind of cool decorative object. But believe me, this was one of the most sophisticated data storage systems in the entire ancient world.
So, the big question is, what exactly was this library made of string? I mean, how did it manage to store so much information without a single written word?
Well, a keeper was this incredibly clever tool used by special officials called quipu kamayoks, which basically means knot keepers. And these guys used these knotted cords to record, well, everything. We're talking census data, tax obligations, calendars, even historical stories. It was literally the administrative backbone of the entire empire.
Okay, so how on earth does a bunch of knots become a super sophisticated data system? Let's, unravel the code a little bit.
The absolute genius of the quipu was its use of a base 10 positional system. It's the exact same system we use today with our numbers. But instead of writing numerals, the Inca used knots. The type of knot, like a simple one or a long one with a few turns or a figure 8, that told you the digit. And its position on the cord told you its value. Was it in the ones place, the tens, the hundreds? It was basically a physical calculator you could hold in your hands.
So here's the really crucial point. The quipu wasn't just a flat list. It was a physical map of data. The length of the cords, their colors, where they were placed in relation to each other, all of these spatial relationships were part of the code. The information was stored in 3 dimensions.
Now, what's really interesting is that while the Inca were using this external physical device to map out information, the ancient Greeks and Romans, well, they were doing something remarkably similar, but it was all happening inside their own heads.
They called it the method of loci, or maybe you've heard of it as a memory palace. So to remember a list of things, you'd mentally walk through a place you know really well, like your own home, and you'd place an image of each item in a specific spot. One by the front door, the next one on the kitchen table, a third on the stairs. Then, to recall the list, you just take that same mental walk again.
And this just illustrates the common thread so perfectly, right? The quipu is external, it's physical, you can touch it. The memory palace is internal, it's all in your mind, and it's visual. But get this, both systems rely on the exact same fundamental principle, using 3D spatial reasoning to organize and get information back. It really is all about location.
This deep connection between physical space and our memory, it brings up a really fascinating question. Is thinking itself a physical process? I mean, can we literally think with our hands?
Well, research into something called haptic perception, which is just a fancy way of saying learning by touch, suggests the answer is a big yes. You see, studies showed that when our brain perceives a letter through touch, it doesn't immediately go, oh, that's the sound ba. Nope. First, it processes it as a geometric shape in space. The verbal part actually comes later.
I love this idea of thinking with our hands. Cognitive archaeologists call it procedural thinking. It's a sequence of physical steps that actually mirrors abstract logic. So tying a knot isn't just a motor skill, it's like a manual algorithm. It's physical computation, finger math.
In fact, you could argue that this simple act was a kind of cognitive scaffold. Think about it. It might have been the thing that trained early human minds in the step-by-step sequential logic that you need for everything that came later, from arithmetic and weaving all the way to the very syntax of language itself.
So if this ability to think and reason in 3D space is so fundamental to being human, what happens when a mind is, exceptionally good at it?
And this is where we get to dyslexia. Neuroscience is showing us more and more that dyslexia is linked to a stronger reliance on the right brain hemisphere. The part of our brain that just excels at spatial, big picture, and 3-dimensional processing. For a mind that thinks primarily in 3D pictures, information gets processed incredibly fast, almost unconsciously. But this creates a pretty unique challenge when that powerful 3D mind runs into a 2D world, like a flat page of text. Okay, so according to the work of researcher Ronald Davis, when a person with dyslexia sees a flat 2D symbol like a letter, their mind's eye instantly treats it like a real 3D object. It circles it, flips it, rotates it, just trying to understand it from every single angle. And as you can see here, when you rotate a B in 3D space, well, it can look like a D, or a P, or a Q. This isn't a mistake, it's just a totally different mode of perception that can cause what he calls disorientation.
And this is so important to grasp. The struggle isn't a defect. It's the signature of a different and in many ways more powerful kind of spatial intelligence. It's a mind that's perfectly built for the real, three-dimensional world, not the flat world of text.
So, this whole journey, from an ancient knotted cord all the way to our modern understanding of neurodiversity, it reveals this really profound and unifying truth. The Inca quipu, the Greek memory palace, the simple act of tying a knot, and even the experience of dyslexia, they all point to the same thing. Our ability to think is deeply, fundamentally connected to how we see and interact with the three-dimensional world around us.
You know, reframing dyslexia like this, from a deficit to a strength, it really challenges us to look differently at all the variations in the human mind. It asks us to question our assumptions, and really it leaves us with this final thought to chew on. What other abilities are we just failing to see?